In this lecture, I'm going to show you how to calculate the moment of inertia of a spherical shell. For this purpose, here I'm considering a spherical shell of radius r. Assume that this is a spherical shell of radius r and mass m. Radius r and mass m. Out of symmetry, here the coordinate system that I'm going to consider is spherical coordinate system. For z-axis, this axis I'm taking as z-axis. Then this is horizontal axis. Okay. First, to calculate moment of inertia of the spherical shell, we need to consider a small strip. I'm considering such a kind of strip at an angle theta with respect to the z-axis. I'm considering a small strip like this. Okay, annular strip like this, circular strip. Okay, so this angle subtended at this by this strip is this length, this direction, the length I'm considering, that is the thickness of this strip is dl. And what is the radius? If you take this as r is the radius of the sphere, then if you rotate this sphere about this z-axis, the circular disc or this circular strip will rotate about the z-axis. Then the radius of this circular strip is given by this distance from here to here. This is the radius. If this is r, this adjacent side is r cos theta, opposite side is r sin theta. R sin theta is the radius of this circular strip. Now, the thing which I am considering, the mass element that I am considering is this one. So, if you divide this sphere into small annular strips like this, one by one, if you keep on arranging, then what happens? We will get the complete shape of the spherical shell. So first, I want to define what is the moment of inertia for this strip. That is di. Di is equal to, if you take this mass as dm into radius of this circular strip is r sin theta. So r square sin square theta. Next, the problem is how to calculate dm. To calculate dm, I am defining sigma, mass per unit area, dm divided by dA, which equivalently we can write it as total mass divided by total area. So through this, dm is equal to what I can write? Sigma dA. Now the problem is how to calculate the area of this strip. This strip is looking like a circle of radius r sin theta and thickness dl, where dl in terms of theta you can write it as dl is equal to r d theta. So therefore, dA is equal to perimeter of this circular strip, that is how much? 2 pi into r sin theta into thickness dl. dl is how much? R d theta. This is the area of the strip that I considered over here. Therefore, through this, dm is equal to what we're going to get here? dm is equal to sigma into dA. dA is how much? 2 pi r square r into r square sin theta into d theta. This is the mass element. So if you wanted to calculate moment of inertia, then what you should do? I is equal to summation over, what is dm? Sigma 2 pi r square into r square, r power 4, sin theta into sin square theta, sin cube theta into d theta. So if you carry out this integration, we will be getting total moment of inertia of this sphere about this axis. Let me call it as z axis passing through the center only. That is nothing but ig here. So what is the limit of integration? See, if you start with theta is equal to 0, and if you keep on rotating this radius vector like this, by the time you come horizontal, half of the sphere is covered, and if you go remaining half also, complete circle is covered, complete sphere is covered. Am I right? So for this purpose, the value of r should keep on changing from 0 to, by the time it is flipped down, it will become 180. So limit of integration will be 0 to pi. So in this, sigma is constant, 2 pi is constant, r power 4 also constant, because I should integrate it with respect to theta only. So now I am showing you how to calculate this integration. For that purpose, I am considering only summation over sin cube theta d theta, how to calculate it between the limit 0 to pi. I'm calculating this integral. That is equal to sine cube theta. I can write it as 0 to pi. Sine cube theta, how you can write it as sine theta into sine square theta. Sine square theta you can write it as 1 minus cos square theta d theta. If you split it, what you will be getting 0 to pi sine theta into 1 sine theta d theta minus sine into cos square summation over 0 to pi sine theta cos square theta d theta. So integration of sine theta is how much? That is simply cos theta only with minus sign. Integration of sine theta is minus cos theta between the limits 0 to pi minus f power n of x into f dash of x. So if you take f of x as cos theta, f dash of x will be minus sine theta. So if you put extra minus over here, this I will make it plus, because again plus into minus minus you will be getting minus only, plus into minus sine theta cos square theta, because the differentiation of cos theta is minus theta. So it is in the form of f power n of x into f dash of x, which is nothing but f power n plus 1. Here f power n of x is cos theta, cos cube theta divided by 3 between the limits 0 to pi. That is equal to minus of cos pi is minus 1, cos 0 is 1, plus 1 by 3 into cos cube theta. Cos pi is minus 1 whole cube is minus 1, again minus 1 you will be getting. That is equal to, this is minus 2. Am I right? Minus into minus plus 2. This is minus 2 by 3. That is equal to how much you will be getting? 4 divided by 3. So this value I am going to use in this integration. Therefore, I is equal to the value of this total integral, that is sine cube theta. This is this whole thing is constant. Sigma 2 pi r power is constant. 2 pi r power 4 into sigma into this sine cube theta d theta I calculated, and its value is 4 by 3. That is equal to 2 pi into r power 4 into what is sigma here? Total mass by total area, capital M divided by total area. Surface area of this shell is how much? 4 pi r square into 4 divided by 3. That is equal to, so 4 gets cancelled here. R square r power 4 pi, everything gets cancelled. You will be getting 2 by 3 m r square, which is nothing but moment of inertia of this spherical shell of mass m and radius with respect to z axis, as this z is passing through the center of the sphere, which is nothing but center of gravity. So moment of inertia of this spherical shell with respect to its center of gravity is given by Ig is equal to 2 by 3 m r square.